we really want to understand, first of all, if we're going to be dealing with this all chapter, which is chapter 12, and yes, we're going through most of it, then we need to know what a rational expression is. Does anyone remember what the word rational means as far as a type of number? There were natural numbers, whole numbers, integers, rational, real. What's a rational number? Raise your hand, sorry. It's something to do with ratio. It is. Jack?
Is it an integer?
It's composed of integers, but a little bit more than that.
Is it a comparison?
It is a compare. Okay, here's what a rational number was. A rational number is any number that can be written as in the form a over b, where a and b are both integers and b cannot be 0. Do you remember that from like beginning of the year? A over b, they're both integers, and b cannot equal 0. That concept, which came from chapter number 1, is going to play an important part in chapter 12 when we're dealing with rational expressions. So I'm going to start off actually with the geometry problem, because most of you are going to get into geometry next year, so might as well throw in some of those problems. That is a parallelogram. That's my best parallelogram. Parallelogram. And I'm going to give you a couple pieces of info. The length of the base is going to be x plus 2. And then we call it the perpendicular height is right here with this dotted line. And then we also give you the area. We give you the area being x plus 6. X plus 6. Yes, ma'am?
It's like, is geometry like higher than
Algebra?
It's up from it, or is it just like?
I honestly, I imagine it as half a step up between Algebra 1 and Algebra 2. So it's like you're going to use Algebra 1 concepts in geometry, but then Algebra 2, Algebra 2 is basically Algebra 1 on steroids, I guess you can call it. I love saying that because it is. It's just like, boom, same concepts, more difficult expressions. You can go into like number theory and
Do you know number theory?
I don't. No. That's beyond me.
What's a number theory?
It's beyond me. No, it's
Look it up on Google.
no. You guys can look it up. You look it up in Google. No, you can also do probability, and that gets really complex. Even business statistics, that gets. I mean, that's not easy stuff. I did get into that because that was more my finance. Okay, but anyway, here I have an area and I have the base. The area of a parallelogram has a formula. It's A equals B times H. I'm just going to give you, base times height. I'm just going to give you a little heads up. If you go, for example, to the east side, you take geometry, basically your last chapter is going to be on areas and volumes of these kind of shapes, spheres, 3D objects, pyramids, all that kind of stuff. And you're literally going to get 10 to 12 formulas. Boom, 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 boom. You have to memorize them all. And some of you are going to be like overwhelmed. Some of you are like, oh, I get that. I get some of it, most of it, all of it. When you're dealing with area, guys, all rectangles, parallelograms, trapezoids, triangles, they all come back to this little formula, A equals B times H. You know what the area of a rectangle would be? What do we say area of a rectangle? Anyone know? Length times width. It's the same thing as base times height. This is your base. This is your height. It's the same thing with the rectangle. And dare I say this? The area of those shapes is related to the area of a circle. Circle. You can actually put it in like this. And that, to me, is so cool. But we don't have time for that. Anyway, what is the area according to this diagram? X plus 6. They already gave us the area. What is the base? X plus 2. What are we trying to figure out then? What is H? What is that height? What is that perpendicular height? Actually, we're just trying to find this right here. How do I get H by itself? Close. You could distribute. Okay, what's happening between X plus 2 and H? They're being multiplied. How can I undo that multiplication? By dividing both sides by X plus 2. And you're like, wait, how does that work out? Ready? What's any number over itself? Any number over the same number is going to give me? Okay. Is x plus 2 a number? It is a number, right? I don't know what it is, but it is a number. What's x plus 2 over x plus 2? 1. So it basically canceled out. What are you left with on the right side? H. Or 1h, right? Which is h. And then what are you left with on the left side? X plus 6 over x plus 2. Doesn't it seem like that? Like 6 over 2 is 3? Actually, it's not. And here's why. Yeah, good questions. Like, can't you make this simpler? And my answer is no. You cannot make it simpler. Do I know what x is exactly? Do I know what x is? No. Throw out a number. We're just making numbers up to see what would work, what wouldn't work. I heard 5. What's 5 plus 6?
11.
What's 5 plus 2?
7.
Okay. So we would have 11 over 7, right? If x equals 5, right? Now, if I made x equal 5, I'm going to rewrite this a different way to help you understand how some things will cancel, some things will not. Okay, isn't that substituting 5 for x? Can I just do that?
Yeah. No, 5.
Yeah, good. It's 6 over 2, which is worth what?
3.
The same thing as 11 over 7. So can I cancel those out like that? No, but can I cancel this out? Make it 3 over 1. What's 5 plus 3? 5 plus 1?
6.
Is 8 over 6 equal to 11 over 7? No. Can I cancel anything out in this expression? No. So I can't cancel anything out in this expression. It's as simple as can be. And yes, that's confusing, but here's the clincher. Ready? You know why these two x's can't cancel out? What's going on between this x and that 6? What operation? Addition. Can division cancel out addition?
No.
Can addition be undone by division?
No.
No. What does undo addition?
Subtraction.
So you could do subtraction, but that's not, we're not looking at, I can't figure that out. So I can't undo addition with division. So I don't try that out. This won't work. Can't do that, can't do that.
Would it work if it's multiplying?
If they were multiplying, yep, I could, and we're going to get to that. But, that's a blast from the past right there. Let's go back to that expression. X plus 6 over x plus 2. You know what? X can be any number other than 5, but it can't be one number. There's only one number it cannot be. What's 0 plus 6?
6.
0 plus 2?
2.
So 6 over 2 would be 3, right? So x can be 0, but x can't be this number.
-2.
I heard it.
-2.
Do you realize, guys, that your denominator can never be 0?
Yeah.
Take out your calculators. Let's do this. What's your favorite number, Jake?
7.
7. All right, ready? Put in your calculator 7 divided by 0.
How do you do that?
You do 7 and then division 0.
Divide by 0.
It says math error.
What? Wait, try it again. Sorry, try it again. You messed up somewhere.
Divide by 0.
Error.
Don't make it suffer like that.
Divide by 0, error.
Okay, how many of you have the word or the abbreviation of error? ERR or ERROR? Okay, are you ever allowed to divide by 0?
No.
No. How about trying this? Oh, because we haven't tried this. Ready? What's negative 10 divided by 0? Did you try it?
Error.
What?
You can't do that.
What can your denominator never be?
0.
Okay, if your denominator can never be 0, that means x plus 2 cannot equal 0, right? What does x have to be for that denominator to be 0?
The reciprocal.
Not reciprocal,
Opposite.
opposite. So in this case, opposite. So what can x not be?
0.
-2.
Negative 2.
Negative 2. Let's test that out. What's negative 2 plus 6? 4. That works. What's negative 2 plus 2?
0.
Am I allowed to have a 0 down there? So we call this negative 2, we call it an excluded value. And guess what you're finding on all these problems? Excluded values. You need to tell me what the variable or variables cannot be. In this case, what can x not be? Cannot be negative 2. No matter what. It can be anything else in the world except for negative 2 because negative 2 would make it equal 0 down there. We don't want that. All right, let's look at this example here. Here's our first real example. So a rational expression, guys, is a fraction. A rational expression is a fraction. That's all it is. And in all these fractions, you're going to have variables. So we might as well deal with that. Okay, I want to find out what x cannot be. So where do I have to look? The numerator or denominator? Denominator. Can the hold on. Can the numerator be 0? What's 0 divided by 7? Put that in there. 0 divided by 7. Is that an error? 0 divided by 7.
Mine is 0.
0.
It should have a 0 somewhere in there. Awesome. I know yours does scientific notation. We're going to figure out how to change that. Okay, so are you allowed to have a 0 in the numerator? Yes. Where can you not have a 0? Denominator. Okay, so this is what I'm going to do. To start this problem out to find those excluded values, I take the denominator and I make it equal 0 because I want to find out the numbers for x that will make this value equal 0. This is a review lesson, a lot of review. So what we're going to do here is say, all right, what do I do here, Mr. A? I need to, here's the key word, factor.
No.
Okay, no, time out. Swivel, you know we practiced this. I was thinking in my mind, how is this going to go? I was planning out my lesson. I couldn't wait to say, we're going to factor. Because you guys were going to say,
Let's go.
there you go. This is the 4th time we're going to deal with factoring.
Yeah.
If you, to use a sports analogy, if you've swung and missed 3 times, technically you're out, right? But this is old school like softball. Oh. So this is girls softball now, okay? You get a 4th try.
Hey,
Coach
Coach
we're doing so bad.
Oh, girls versus guys?
Yeah, they got 17, we got 6. No, it was 14.
Go girls! Yeah, you can do
But they
it.
got 5 out, so we got 2. So.
Yeah.
All right, the first thing I want to do, guys, is get the GCF. Is there a GCF between these two? Between this and this, is there a GCF? X, good. There's a GCF, it's X. Yeah, go ahead, thank you. What gets left in the parentheses? X plus 3. And then that still equals 0. Thank you, sorry about that, Braden. Okay, here's the next step of the review. 2 numbers are being multiplied and they get me 0. What does that tell me about those numbers? They equal, one of them or both have to equal 0. Good. So this is how I set it up. Either x equals 0 or x plus 3 equals 0.
How do you do x squared?
Sorry?
Like, how did you get that? Or like, how did you get that they equal 0?
Right here or here?
Like, how did you?
Remember, what do we not want the denominator to be?
0.
So then I make it equal 0 so I can find out what are those numbers that will make it 0 because then I want to exclude them eventually.
Like numbers.
Good. Sometimes number, sometimes numbers. Now, let's see if that actually is going to play out here. What does x, okay, can x equal 0? Like right here, is that possible? Yes. Is that possible? Yes. So what can x not be?
0.
What can x not be there? Remember, you're just solving? There you go.
Wait, so I did it like the normal way that we did like before,
Mm-hmm.
and I got negative, or does not equal negative 30. Could I have just done like does not equal 0? Like, could I have just added that?
No, because sometimes 0 is excluded value, sometimes it's not. It just depends on the problem. But guys, this is how I can know for sure. All right, did I say x cannot equal 0? Yes. What's 0 squared? What's 3 times 0? 0 plus 0? It gets me that awful number in the denominator, which is what I don't want. What's that number? 0. So can x equal 0? No. What about negative 3, though? I'm pretty sure that can fit. But let's see. What's negative 3 squared? 9. What's 3 times negative 3? Negative 9. What's 9 plus negative 9?
0.
So can x equal negative 3? No. These are the two, and I'll put it here for your notes. Excluded values. So are there only, sorry, I should say this correctly. Is there only one excluded value in every problem? No. Sometimes you can have 2. Sometimes you can have 3. And other times you may have, you can have as many as you want. As long as they fit it. I shouldn't say as many as you want, but as many as are there, because some do have a lot of excluded values. Okay. Any questions on how to find the excluded values? Good. Find the excluded values.
You said you can't divide anything by 0.
Yes.
But is 0 over 0 is 0?
Can you put that in?
Because
Put it
number
in.
over itself is, or like,
Let's see, Sarah. What does this high-tech calculator say? Okay, so yes, a number over itself is always 1, except for 0. 0 is a special number, so special we study it many times throughout the year. I like 0 one day, and I hate 0 the next day. Good question. What can A not be? That's what we're asking, right?
Well, there's
So-
no.
Oh, bummer, you're right. Hold on. A squared minus 5a plus 6 cannot equal what? Okay, so I said it's equal 0. And I have to factor it. Is there a GCF? No, but can I factor it?
Oh wait, you know
What kind of polynomial is that? Trinomial. It has a 1 in front, which means I can do this. Remember this review? You can factor it into 2 binomials. A goes in the first spot. What numbers go in the second spots?
3 and 2.
Which one is it? Because one's positive, one's negative. Negative 6 and 1. I heard 2 other numbers. Which ones are they?
Negative 3, negative 2.
Negative 3 and negative 2. No, it's
Negative 3,
negative 2.
All right, here's how we check it. What's negative 3 times negative 2? Positive 6. What's negative 3 plus negative 2?
negative 5.
So that's the only one that works. I think 6, what was it? Someone said negative 6 and 1. What's negative 6 times positive 1? Negative 6. That won't work. These are the ones that work. All right, so I have this. If 2 numbers are multiplied and they get me 0, what do I know about those numbers? They have to equal 0. So a minus 3 equals 0, or a minus 2 equals 0. So what would a be here?
3.
A would be 3. What would a be in this one? 2. So what are the 2 numbers that a cannot be?
3 and 2.
3 and 2. So I put this little slash. Those are my excluded values.
Is that all we need to put as the answer?
For the excluded values. If they asked for excluded values, that's all I wanted. What can a not be is what I was asking for.
3 and 2.
Yes, good. And so that's how you do it? That's how you put it. How many of you can get excluded values? Are you doing okay with?
Yes.
Yeah, because I don't want it to be distracting where you're losing track of this. Ma'am?
Can it be any, could A be any numbers besides those 2?
Any number besides those 2.
Except for 0?
Nope, 0 would work. Let's see if 0 works. Because is 0 an excluded value, by the way? No, not according to that. Let's see. What's 0 squared? What's negative 5 times 0? 0 plus 0?
0.
Plus 6? Ooh, so what do I get down there? I still get 6, which is okay. So A can be 0 in this problem. All right. On page 307, I want you to do number 1. Find me the excluded value for y plus 6 over 2y plus 12. You're allowed to begin. So this is the try these on page 307. Number 1, find any. Whoa, hold on.
We can do what we did
It's a, that's just an example of an application of the problem. Yeah, so you're not going to have to deal with the parallelogram, but it just gives us a reminder of geometry. I'm sorry, I'm reading the instructions. It says, find any excluded value of the domain. What's domain again?
Any real number.
Now, what's the domain referring to? X values. So that's all it's asking for, X values here. And you're like, wait, but that's Y. Okay, there's only one variable. That's your domain. That's all it's saying. That's the independent variable. So if you see domain, don't get scared by that. What I'm trying to say is they want you to find the excluded values of the domain. And what does the domain normally refer to? X values. Do you have any X values? So technically your domain is Y. So does your domain always have to be X? No. Sometimes it could be Z, Q, T, D. In this case, it's going to be Y. So just go ahead and figure it out. What can Y not be? That's what I'm asking for.
So that was
Yeah, find the excluded values. Yeah. Sorry, make 2y plus 12 equal 0. Remember the denominator. Look at the denominator. That's okay. I think domain, maybe you're referring to domain as numerator. No. Domain is variables. So
Yeah, I think it's numerator.
So we only do the bottom?
can the top be 0?
Yeah.
Can the bottom be 0? So I'm just dealing with the bottom. Yep, just deal with the bottom. Okay, I factor the bottom. Is there a GCF of the 2y plus 12?
2.
Good, 2. And what's left? Y plus 6. It's got to be y plus 6, and that equals 0. Okay, two numbers are being multiplied, and they get me 0. So what do those two numbers have to be? Or could they be? 2 equals 0, or y plus 6 equals 0, right? Does anyone have a problem with one of those equations?
Yeah.
What is
What's your problem? Which one? This one right here. This one I'm not even going to deal with because it's just a number. Can 2 ever equal 0? No, so you drop it out. I am going to deal with this one right here. So if you get a number that's factored out by itself, you don't even have to deal with it.
The numerator will get you the same thing as the answer.
Well, in this problem, but that's not always the case. It just happens to be. Okay. Yes, ma'am.
I did it like where I did it wrong, but then I still got the same. I did like divided by 2.
Yeah. I mean, that's when you factor, you divided both of these by 2. Yeah. And so here's what happened. Because this 2 really didn't mean anything for this type of problem, you still were okay to get y plus 6, but it might not work out that way if you had like a 2y. If you just deleted that, you would get something wrong. So it just happened to be the right one.
I didn't really factor. I just kind of to like try to solve for y.
Congratulations, good luck.
This so does it always hurt?
No, it doesn't. Yeah, sometimes you have to work it out, as you'll see in other problems.
Sorry, should I be y not?
Yes. Yep. Y does not equal -6. Good. So what's the only value that y cannot be? -6. Can y be 0?
Yeah.
Y can be 0. Do you see y? The other y. What's 2 times 0? 0 plus 12. I got 12 down there. What about -6? What's 2 times -6? -12 plus 12? 0. That's no good. That's my excluded value. Okay. We're going to move on to this next part, which is taking it one step further. So write this rational excluded value. No. Rational expression. All right, in this problem, it says to simplify, make this simpler, and identify any excluded values. Let's do what we've been doing before. Let's get those excluded values. What do I have to look at for excluded values? The denominator, the bottom. So I'm going to take 5x cubed plus 3x squared equals 0. Okay, I want to deal with that. Is there a GCF for that
X.
polynomial? Sorry?
X squared.
X squared. What's left in parentheses?
5x plus 3.
All right, good. You guys agree with that? You guys okay? You just factored out the GCF, and I can't factor that anymore. It's not a trinomial. It's not a difference of two squares. I'm done. This times this equals. So what do I know about each one of these? X squared equals 0, and 5x plus 3 equals 0, right? Solve for x on both of those. Ooh, wait, x squared. How do you solve for an x squared? What undoes squaring? Square rooting. I get x equals, technically, the square root is 0 is 0, but remember? Plus or minus. But what is plus or minus 0 is just 0. So please don't forget that that's a reminder that technically you got two answers, but in this case they happen to be the same. So we're fine with that.
I don't understand how you go.
That's okay. Just pay attention, keep writing. How do I solve for x over here? Good, subtract 3, and then, sorry? Nice. And what do you get for x here? Okay, you get x equals negative 3/5 and x equals 0. So what can x not be? Yep. So those are excluded values. Those are excluded values. Those are the values that cannot, that x cannot be. Those two right there. All right. But what else did they want me to do here? Simplify. Make it simpler. And you're like, why would I want to do that? Because in future lessons, you're going to have to add, subtract, multiply, and divide. And don't we like making the numbers simpler before we do those things? Yes, I like doing it. I hope you do too. So here's what we're going to do. To simplify, you want to factor the numerator and denominator. Can the numerator be factored anymore? No. It says factors. There's only one term. You just leave it alone. But the denominator, I do have to factor. Oh, wait. We already factored it. Do you remember where I factored it?
X squared times.
It's right here. Just rewrite that. X squared times 5x plus 3. No, it's the same problem right there. But it's another step. Yes, this is something else we have to do. Okay, now, here I have a factored numerator and denominator. Can I cancel anything out? Take guesses at it. Let's just get.
X squared.
What about this x and that x?
No.
Wait, why not?
Not anything.
9x squared has
They're not the same thing.
Added.
They're not like terms.
Okay, here's what it is. When you have something in parentheses or a binomial, this comes as 1. If you cancel one part, you got to deal with the whole thing. So I guess I'm going to rephrase that. You can't just cancel one part and not deal with the whole thing. So can I cancel this x squared and that x squared? Yeah, what's x squared over itself? 1 over 1? Do you guys agree with that? X squared over x squared? Okay. What's 9 times 1? 9 times 1. Good. What's 1 times 5x plus 3? Can I cancel any? Ooh, can I cancel anything else?
3.
And then
No, you can't.
No, you
because
cannot.
That's
No.
simple.
No.
okay.
Why?
No.
Good job. No.
Because you're adding.
I get the no.
Division.
Yeah, these are being added, so I can't just cancel these out because you can't undo addition with division. So this is as simple as it gets. So yes, you need excluded values and a simplified answer.
Can you do one more thing?
Yeah, oh no, we're going to do a couple more actually. We'll do a couple more. How about that? All right, let's look at this expression here. I'm going to find excluded values or value and simplify it as much as I can. So let's go with the excluded values. So what do we have to look at? The denominator. So negative 6a equals 0. So what can a not be? Ooh. I'm going to solve for a, right? A cannot equal. Plug that into your calculator.
Error.
No, it's not error. 0.
What's 0 over anything? So what can a not be? A cannot be 0. That's the only thing it can't be. That's the excluded value. So far, so good. You guys get the excluded value?
Do you need to like simplify?
Yeah.
Then we need to simplify it, yeah. So we first find the excluded. All right. Can I simplify, or sorry, can I factor out the numerator? Can I factor anything here?
Well, I don't.
Yeah, 3 can come out. You're left with a minus 2. Can I factor the denominator anymore? No. It's one term. When you take a 3 out, if you divide both of these by 3, factor.
Oh.
Sorry. Is it late in the day? You guys look tired. I get the honor of teaching you right before
It
7.
keeps on popping and then hitting back in my shirt.
I haven't noticed that, but yeah, I guess it feels like that maybe. Okay. What can cancel here?
There you go. Wait,
A.
but they're connected.
Yeah, are these two connected by addition? So they're being multiplied, right? Okay, cool. What's going on with this 3 and that a minus 2?
Wouldn't that be negative 2 then?
Oh, well, yeah, I didn't cross out the negative yet. So what's 1 times a minus 2? A minus 2. What's negative 2 times a?
But when you're not.
Simplify.
Okay, are you thinking about the a's?
No, not.
Why not? Why not?
Because it's subtraction and not.
If these two were being multiplied, you could cancel that out. But they're not, so I can't. That's as simple as it gets. Ultimate problems coming up. Yep. If you get this problem right individually, so this is you, not class. If you get it right, you can start the homework. If you get it wrong, you get another problem to help you out. On page 307, the try these, number 4.
No.
I had to go with that one, didn't you?
I did.
I have a sudden illness where I can't do math.
Well, that's unfortunate. That's
Yeah,
called,
it's very sudden.
Oops. Okay. Could have been mad. And so this is number 4 on page 307. You get, I mean, it doesn't help you for this problem. It really doesn't.
That's a little awkward.
Which one do you?
So we're trying to find excluded values. So we make the denominator. Yep, looks like you did it. So I'm going to put that in.
This is a tragedy.
All right, is there a GCF? Same questions I've been asking.
You are.
P, Q, R, and what's left? R plus 3. Just get that GCF, just like you've been doing. Same thing. Do you guys see that PQR was the GCF? Okay, so you factored that out and you were left with R plus 3. Remember I said you can have up to 4, well, you can have as many as you want, but I did mention 4 excluded values. P times Q times R plus 3 equals what? What can P not be? 0. What can Q not be?
How did you get that? 0.
What can R not be?
How did you get that?
0.
And there's one more that I need you to find.
But how did you not?
Oh, you say it, you write it down because it's kind of long.
How can you just say PQR?
How did
You could say PQR cannot equal 0, but no, sorry, like that's possible, that is true, but each variable, excluded values, you're talking about each variable.
How
Yeah, simplify it too.
Are they always gonna equal zero?
Without even doing it.
Yes, but I need to, sorry, answering Parker's. Yes, just all equals 0. But there's one more. R can also not be. Good, -3. Can't be any of those.
How did you get
And the simplification.
Wait, how did you?
How many of you got the excluded values? Okay, you will not get home. Okay, you will not get extra problem.
Yeah, finish what we want.
But we have to finish this up. Let's factor the numerator and denominator. Didn't we already factor the denominator? Yeah, so don't worry, you're not going to have to do it twice. You just rewrite it. P, Q, R times R plus 3. But the numerator we can factor, what would that be? PQ times R plus 3. All right, here's the fun part. Yeah, there you go, that fun. What cancels out? Okay, the P's, that's 1 over 1. The Q's, that's also 1 over 1. Hold on.
No, nothing else. Wait, R plus 3, R plus 3.
R plus 3 and R plus 3 can cancel out.
So it's just 0 over R.
No, not 0.
1 over R.
Okay, yeah. What's 1 times 1 times 1? 1. What's 1 times 1 times R times 1? That's the simplified version. You get used to it. It is. It's not easy, but thankfully they're not that bad.
Not that bad.
Yeah, they can get to that level, but not yet.
Perspective of not bad is totally different than not.
Uh-oh.
But just like,
2 to 14 even. Who didn't get both parts correct the first
I
time?
didn't understand how you got to that.
Okay, that's all right. Try out number 3 and let's see if we can get it on that one. On the try these, do number 3, then start that up. Anyone else? Because I don't think she's the only one.
Don't all get that.
I am, but I'm not going to read it here because I'm doing
Good, number 3. Thank you for raising your hand.
I am not the only one who did not get that.
well, I didn't do it.
Good day, guys. Yep, we gotta go.
It's